Okay, great. So good morning, everyone. Today we have the pleasure to receive Dr. George Beckett as the speaker of our weekly webinar. Dr. George Beckett obtained his PhD at University of Strathclyde in Glasgow, UK. And since then, Dr. Beckett has been working as software engineer and project manager for 15 years at Edinburgh Parallel Computing Centre, EPCC, of the University of Edinburgh. And during this time, he managed various high-profile international projects and delivered successful outcomes for many of these challenging projects. And currently, he is the LSST UK Science Centre Project Manager. And today, he kindly agreed to share his experience with us and talk about the UK ambitions for astronomy in the LSST era. So, dear Dr. George Beckett, thank you very much for accepting our invitation to give this webinar. It's really a pleasure to receive you here. We are very excited to hear what you have to say about the UK plans for LSST. Okay, so please feel free to start your presentation, okay?
Great, thank you very much, and thank you for the introduction. The technology seems to be working pretty well right now. However, if there are any problems, just shout and we can hopefully work around them. So thank you for inviting me to speak today. As has been said, I'm going to tell you a little bit about the UK's ambitions for being part of the LSST telescope project. Some of the things we're doing just now here in the UK, what our plans are, and also the potential opportunities around an international DAC, which is something that people in Brazil may also be interested in, although actually I have less to say about that than I had hoped, in that the formal details are still to be confirmed, but I'll tell you what I can, and if it's something of interest we could maybe follow up in a future discussion. I'm going to start with a disclaimer. I think this is important before I speak to you and make a fool of myself. I am not an astronomer. I've worked with astronomers for a number of years, so I know some of the language, and I understand to a certain level the ambitions and the research that they're undertaking. But if you do have specific questions about the astronomy related to this talk, then the best thing I can do is take those questions offline and get back to you afterwards. However, hopefully I'll be able to answer most of your questions today and still give you an interesting talk. As you've heard, my background is actually in high performance computing and scientific computing. And within LSST and within the UK part of LSST, my focus has been on the technical challenges of, if you like, how to connect astronomers with the telescope and how to give them the maximum opportunities for new science. I'll briefly run through what the LSST is. I think one of my colleagues, Ian Shipsey, spoke to you last year, and so may have covered some of this already, in which case I'll go quite quickly, but I thought it was worthwhile just reminding us all what is LSST and what is it planning to do. So the Large Synoptic Survey Telescope is currently in construction. Actually, if you go to the website for the telescope, you'll see it is progressing very well. Construction is nearly complete now, and there is a reasonably substantial facility there. It's being built in northern Chile, and it is groundbreaking in a number of senses. First of all, it's very large. It will have a very wide viewing angle and a very deep sensitivity. It's also a very fast telescope, which means it can image the sky in just 3 days, the visible sky in just 3 days. It is synoptic in that it will be able to image in 6 different color bands, which is quite a lot for an optical telescope, I understand, and hence will give a very deep picture of the whole sky. And the intent is that it will create a survey. So this is covering the whole sky and producing a reference catalog and reference data sets that will then be usable by astronomers and interrogated by astronomers to do their research. It's a 10-year survey. It's due to start in 2022. and I think it's pretty well on track to start in 2022. As we get closer to the beginning of operations, the risks of delay diminish, and I think barring anything unexpected and serious, it should start operating in 2022. And it will image 30,000 square degrees of sky, and it will complete that survey every 3 nights over the 10 years, which means that, roughly speaking, given a little downtime, it will create 800, it will image each part of the sky 800 times. This gives you a number of opportunities. First of all, by stacking the images that you create of each patch of the sky, you can actually build up a catalog of very faint sources, far fainter than has been observed previously. And it's expected that LSST will see roughly 20 billion galaxies and 17 billion stars in our galaxy, which is a very large catalog, as I'm sure you can imagine. Also, because you have so many images of each part of the sky, effectively you have created a movie of the sky over 10 years. And so this makes the telescope very attractive for those interested in transient astronomy. One of the sort of foci I'll mention briefly that the US have raised is the opportunity to detect near-Earth objects, objects that are moving in the sky that are too faint to be seen now and that aren't observed sufficiently frequently to be able to model and map their form and their behavior. In terms of technology, I believe this is still the case, is the largest digital camera that's ever been made. It will have 3.2 gigapixels, and the camera will have a field of view of 9.6 square degrees. The survey that's going to run over the 10 years, 90% of that time is for the baseline survey. But 10% of the time has been reserved for 8 focus surveys that will go to extreme depths. And the targets of those 8 fields is still to be determined, I believe. But there is a discussion in the community ongoing about the best selection of those 8 fields. In terms of costs, the construction budget is $640 million US, and the predicted operational budget will be $370 million US. So not an insignificant amount, but a viable amount for a telescope. Much of that funding is from US agencies. So NSF in the US, sorry, and the Department of Energy are both key contributors to the project as a whole. However, around about $100 million US of the operational costs is being raised through international contributions. And this is the way in which the UK has become involved in the project. The primary science drivers that the project, and by the project I mean effectively the US Chilean group that are responsible for designing, constructing, and then operating the telescope. The science drivers that they have identified are listed here on this slide. So understanding the dark universe, being able to better model dark energy and dark matter, creating an inventory of the solar system, or a more detailed inventory of the solar system, cataloging the transient sky, and mapping the Milky Way. And to help realize those drivers, those focus, they have established 8 international science collaborations. And I've listed them there. If you click on that link, or if you note that link, you can go and get more detail about those collaborations. They are open to anyone potentially. Depending on the collaboration, you may or may not need to be a subscriber, and I'll explain a bit more about that, but potentially anybody is able to join these collaborations and hence contribute to the planning for science within the LSST. I'll look a little bit at the data that's coming out of the telescope, as that's sort of one of the focus areas that I have to worry about in my role. So the first thing to note is that data is proprietary from the telescope, and for a period of 2 years after it's observed, data will only be available to data rights holders. There are 2 ways in which you can be a data rights holder. One is if you are an astronomer based in either the United States or Chile, then you automatically have access to the data from the telescope. The alternative is, if you're not in either of those countries, is you can subscribe on an annual subscription basis. I'm not sure the exact figure at the moment. I think it's around about $20,000 US per year, but that would be worth checking. It may have changed slightly. The data that's produced will actually be hosted in 3 different centers around the world. The first one is in Chile, very close to the telescope site. That will both host the data and provide what's called local computing for Chile-based astronomers to analyze data. The largest facility is in the USA, in NCSA, and there they will both host the data and provide local computing, as the Chileans will, but furthermore they will be responsible for half of the processing. So the raw data is converted into various data products that I'll talk a bit more about later. This will be done by the US team at NCSA. I see there's a typo on the slide there, sorry. And also by a team in France at IN2P3, who will also host a copy of the data. Note that France does not necessarily provide local compute, so it isn't necessarily the case that astronomers will be able to go to IN2P3 to analyze the data. France's involvement is primarily around dark energy and the particle physics groups, their interests in dark energy, and they may take a different route towards analyzing the data because they have very specific compute requirements for that. Here in the UK, we're also planning to operate a data access center. However, it won't be what's called an official data access center. And by that, I mean it's not funded by the project. It will be funded separately through primarily UK government funding that we're working to secure right now. And our ambition is to host a full copy of the LSST dataset and to provide compute resource for at least UK-based astronomers to do their analysis. I say at least because we are also interested in supporting a wider community of astronomers. Many, as I'm sure you're aware, of the most successful astronomy collaborations now involve international teams. And we would like to enable that kind of science on UK infrastructure. The data that will be produced by the telescope falls into 3 classes. First of all, there is a set of immediate data called prompt products, which is effectively a difference imaging of each image against a reference image. And this is where the transient science will get its first look at LSST images. On a nightly basis, it's expected that LSST will produce what's called an alert stream of roughly 10 million objects. Some of these will be bogus. However, it's expected the majority of them will be genuine transient events on the sky, either interesting or not interesting. And this alert stream will be a reasonably rich feed. It will contain quite a lot of metadata based on an initial analysis, and it will also contain image data, at least postage stamp level image data. Now, this alert stream is actually a public stream. So whereas, as I said earlier, much of LSST data is proprietary, the alert stream will be public. However, accessing the alert stream has to be done via what's called a community broker. The alert stream is actually quite a dense stream, as you can imagine, that requires of the order, I think the figure is currently around 10 megabits per second to process. And so the intent is that there will be a small number of community brokers that will receive these feeds and then relay them to a wider community. The second class of data is called data release products, and these are the major catalog and image repositories that will be produced on an annual basis. There will be actually 11 data releases planned across the 10 years of the survey, but that's simply because there will be a first data release after month 6 of observing. And then the second will be month 12, month 24, month 36 and onwards. So these are the go-to products for most astronomers. They will contain processed images and very detailed catalog analysis of all the sources and objects that have been detected by the telescope. Third class of data is actually not project data at all. It's called user-generated products. And this is the data that is expected the community will derive from either data release or prompt products. Much of that data will actually have rather wide interest in its own right. And so there is at least a high-level plan for that data to potentially be reincorporated into the LSST repository so that it can be published for a wider community. If we look at how this lays out on a map, then the base site in northern Chile will first of all relay the data to, the summit site in northern Chile will first of all relay the data to a base site very close by, where a copy will be maintained. There is then a high-speed link, which I think is 4 by 10 gigabits per second already, to NCSA in the US. And so all of the data will be transferred there. And then it will further be relayed across the Atlantic to a country I haven't displayed on this map called France, where half of that data will be processed. The alert stream, the prompt products that I talked about earlier, they will be published by NCSA, and specifically for the alerts, the target is to release these images within 60 seconds of observing. So that's quite an ambitious target, which will allow effectively pseudo real-time astronomy and follow-up. Sorry, here's a little bit more about those prompt products. I should have moved to this slide earlier. So as I said, the anticipated level is around about 10 to the 7, so around about 10 million alerts per night. And these will be published from NCSA, but available to the community via a collection of what are called community brokers, which will be distributed internationally. Data release products typically will contain a whole set of different processed data sets. You'll have the per visit images that have been cleaned. You will have catalogs that are generated from those images. You'll have COAD images for deeper sensitivity, COAD catalogs, and pre-visit force photometry. And I have to say, every time I give this talk, I think I better go and find out what pre-visit force photometry is. I don't know, but hopefully you do. If you don't, I can find out for you. And user-generated products, again, these are beyond the scope of the project, but they are likely to be important to a whole range of different science applications. And as I say, it is hoped that the teams and the collaborations that produce this data will republish it to LSST so that it can be shared with a wider user base. Here's another slide just showing that breakdown a little more. I don't think there's anything particularly new on here, so I will, in the interest of time, skip on to the next slide. So alongside the construction of the telescope, there is a significant team primarily based in the US called the Data Management Team, and they are building a software stack called the LSST Science Platform, which is the way by which astronomers will gain access to the data as it's produced. The platform, which is sort of laid down in this graphic here, will provide various low-level services for the data releases in the alert stream, as well as some high-level interfaces for the user. And there are 3 interfaces that are planned. The first one is a portal, which effectively will provide a relatively simple access route for astronomers via a web browser to perform standard queries against the catalog, potentially some very basic image analysis and image manipulation work. The second interface is an extension of that portal, which is a set of Jupyter notebooks or a notebook service. So you may or may not be familiar with these. In some sense, this is a bit like a workstation in a web browser. It allows you to do the kind of things you would normally do on a workstation, but without the need to install lots of software locally and to have a local access to a copy of the data. You spin up a web browser, and within that web browser you get a scripting environment or a shell environment where you can type typically Python programs or applications and run those interactively in real time. You then have the option to share those notebooks with colleagues, collaborators, and potentially to work collaboratively on them. The big advantage is all of the complex software that's needed to analyze the data is part of the notebook, so you don't need to install it, and the data that you're accessing is close to the notebook. So again, you don't need to download that data. Third approach will be via a set of APIs which will be available, likely to be in line with the IVOA standards, and these will be targeted at more specialized users who wish to build their own analysis software and then interact with the data more directly. So for example, the dark energy science collaboration that I mentioned previously is likely to want to do their own analysis and not to use either of the sort of more user-friendly, pre-prepared mechanisms that come with the portal and notebooks. So that was a quick overview of LSST. Probably much of that was a reminder of what Ian had spoke to you about previously. I'll have a quick pause now in case there are any questions or comments, and then I'll go on to what we're planning here in the UK. And I'll take a drink of my tea. Okay, I'll take that as a prompt to continue.
Yeah, please go ahead.
Sure. So here in the UK, recognizing the significant opportunity that LSST brings, especially as we haven't paid any money towards the construction, we have formed a consortium, and the consortium actually now has representation from every single astronomy group here in the UK. There are 35 of them across mostly university, but also research labs and observatories, all listed on this slide. And together they have agreed to collaborate on exploiting LSST and contributing to LSST.
Just a quick question. I mean, that doesn't mean that all UK astronomers will have data rights, right?
It doesn't, and I'll come on to that in a moment.
Okay.
So it's actually the slide after this one, but I'll stick to the track just now. So the interests in the UK are across all areas of LSST, the areas that I noted earlier, but in particular at the moment, we are very active in 3 of the international science collaborations. If you remember, I mentioned the 8 collaborations that have been set up, and those 3 are the Dark Energy Science Collaboration DESC, the Transients and Variable Stars Collaboration, and the Galaxies Collaboration. I say we're most active in that we have the greatest membership in those, UK representation is greatest in those. Doesn't necessarily mean we have the majority representation in those groups. And the kind of aspects that this covers and the impact it will have potentially on our data access center is work on multi-wavelength analysis. And this is effectively cross-referencing LSST data with contemporary data from other surveys that UK astronomers will have access to. Transients. Already there is a sizable interest in the UK and some expertise in handling transient astronomy. And we are in fact bidding to be one of the community brokers and are building up a prototype infrastructure, which I'll talk a little bit later, to both support that, but also to do useful science in its own right. And we're also very interested in the workflow of triggering follow-up observations, in particular around spectroscopic follow-up, because LSST is an optical telescope, and it's expected that a number of science applications would benefit from quick spectroscopic follow-up, and we have opportunities to do that through various surveys, various telescope facilities that I'll mention on the next slide. So this is a list of all of the major telescope projects that the UK is currently involved in. Some of them are public, some of them are proprietary, but we believe we're in a very good position because by combining the information that can be gleaned from each of these telescopes, potentially you can get more science out than you could with, for example, just LSST alone. So we have Gaia, which is a successful optical telescope, which has been in operation since 2013, I think, maybe a little bit earlier. Launch was 2012. Various spectroscopic surveys, MOONS foremost is particularly interesting when it comes online. Euclid, another space telescope, WEAVE and DESI. Infrared through UKIDS and VISTA, which are running just now, and again Euclid will provide infrared. And in radio astronomy, the SKA telescope, or telescopes, I guess, which are due to come online early in the 2020s. So coming back to the question earlier from Luis, the consortium has secured data rights for 100 PIs and has secured funding for that. So we already have a program in place where those PIs are appointed and refreshed each year. As well as the 100 PIs, each subscription you have also gives you data rights for 4 junior staff in your research team. So effectively we have 100 PIs, but plus 400 more junior sort of postdoc level, potential PhD level researchers who work in those teams, which gives us an aggregated total of 500 researchers, which is a sizable chunk of the UK community, but not all of it, as you've said. In fact, when I first joined LSST and I knew there were 100 PI slots available, I wondered if we had enough astronomers in the UK to fill them. And I was quickly shown that actually we did. And in fact, there is quite a lot of demand for those slots, which is a good thing. The consortium is also cooperating on a program of preparatory and during operations actual science activities, which we've divided into two categories. We have a set of activities towards the establishment of a UK data access centre, identifying the capabilities and how to deliver them, and also furnishing the infrastructure on which it will run. And in the UK, actually, our approach is somewhat different to what has been done within the project, which may be interesting, and I'll talk a little bit more about in a few slides. And then we have a number of what we call dev or development activities, which are about establishing the capabilities and the technology that will allow us to produce user-generated data products very early on in the telescope operations, aiming to maximize the chances or the opportunities to do science with the telescope. If I look at the program as a whole, we've broken our program down into 4 phases, and we actually began work on LSST engagement 4 years ago. As we speak today, we're coming to the end of phase A, which is our development phase, and phase B, which is almost funded. I'm pretty confident it's funded, but I'm still waiting to release the piece of paper, is due to start in around about 3 weeks' time. And that is what we're calling our commissioning phase. And between now and the end of phase B, we will ramp up our activities, aiming to be contributing to commissioning of the telescope and, in fact, early operations before the end of the phase. Our forecast budget for the whole program is £32 million, but that does not actually include a budget for the infrastructure on which we would run. The reason for that is, as I hinted at earlier, our infrastructure provision will be slightly unusual. The main funding body here in the UK for us, which is called STFC, the Science and Technologies Facilities Council, has said that they will not fund dedicated infrastructure for LSST on its own. And in light of the fact that there are a number of significant projects, not just in astronomy, but also in particle physics and nuclear physics, they are funding a shared infrastructure, which is a mix of high-performance computing and cloud computing resources, and is called IRIS. And IRIS is the platform on which we will deploy our data access centre, and on which UK-based astronomers will do their science. So phase A, which is coming to an end, was a relatively modest £2.7 million investment, which was led by Edinburgh. Bob Mann, who you may or may not know, is the PI for the project. I'm the project manager and also technical lead. And in fact, both of us will carry on these roles into phase B. Here in Edinburgh, we are leading the DAC part of the program, and we have roughly 6 staff years of effort, which has been used, and I'll talk more about this in subsequent slides, to develop a testbed implementation of the DAC, to contribute to various data challenges that the science communities, science collaborations are running, and also to support the early work of the development projects. Within phase A, we've also had roughly 16 staff years of funding for development projects, which has been split across 6 institutions. I probably should have written them out in full rather than assumed you would recognize UK institutions, but there's Manchester, Cambridge, Queen's University in Belfast, Southampton, University College in London, and Oxford. And the development activities are focused on weak lensing towards the dark energy, mapping of dark energy with the telescope, Milky Way science, transients, solar system science, and also in terms of the construction on sensor characterization work. And I'll mention that again briefly later.
May I ask a question, George?
Sure, go.
First of all, are you working with the people in operation, construction or operation with the LSST in the US? Or are you doing that by yourself?
So We don't work with people in construction particularly, although the team involved in the sensor development are engaged with that, and that's the team that Ian Shipsey leads up. And I don't know if he talked about that when he talked, but as I'll mention in a few slides, we are developing, or the UK manufacturing is developing the sensors for the camera. And Ian's team has been closely involved in that work, and hence has been involved in the construction.
Well, I see that you have about 22 FTEs, right, for both programs.
Yes, across phase A, we had roughly 22 FTEs.
How many people that they represent, and which is the split between engineers and scientists?
You're right, the 22 FTEs was split more than across 22 staff. We had a number of part-time appointments. In part, this was because we have staff that work both on LSST and other contemporary telescopes, and actually sharing knowledge between them is a positive thing. I don't have a handle on exactly the figure. I would guess we have probably a team of around 40 people that have some of their time funded by this program towards LSST, plus the roughly 300 people with data rights now in the UK, which is, I think, 90 PIs, and then a little over 200 junior associates associated.
They are all contributing?
So the PIs and the JAs, the people with data rights, typically contribute as scientists, whereas the people that are funded from the Phase A program typically contribute as engineers. It's not quite as black and white as that, as you can imagine. Yeah. There is overlap between people who are interested in the astronomy of LSST and the engineering of LSST, but at least at a high level, it's fair to say that the funded Phase A work is engineering, and the data rights holders are science and working through the science collaborations.
Thank you.
The other thing I would note, I think you asked a little bit, was we do have a good relationship with the operations team, and in particular what's called the LSST DM team, the data management team. And so whilst we've worked mostly independently of them, as we approach the beginning of operations, some of our activities are becoming interesting to them and useful to them, and we are getting more closely engaged, aiming to be fairly full contributors to commissioning. Okay, so yep, the DAC team here in Edinburgh is drawn from a group called the Wide Field Astronomy Unit, who actually run UK archives for a number of other astronomy surveys. So UKIDS and VISTA are our main surveys just now, but we're also part of data management for the Gaia telescope and do data processing for Gaia, and we're also significant role in the Euclid telescope, which is due to launch early next decade. I think 2022 is the current launch date. The kind of activities that we've been involved with more generally in the Wide Field Astronomy Unit are, we are developing the science platform for Gaia, which has a number of overlaps with the science platform that's planned for LSST. We are involved in the preparation of data processing for the Euclid telescope, and we're also pretty active in the European VO standards bodies. There are two projects which are funded by the European Commission called Asterix and Escape. I'm not suggesting you'll recognize those, but if you were interested, if you were to put into a search engine European Commission Asterix or Escape, you should be able to find the pages pretty quickly. And we also have significant expertise with supercomputing here in Edinburgh. So I think, as mentioned at the beginning, my main job is actually in EPCC, which is the supercomputing centre here in Edinburgh that runs the UK's national service machine Archer, as well as several other significant HPC resources for UK and European academic research community. Our objectives during Phase A have been to understand and to prototype the technologies that will make up a UK data access centre. Our philosophy has been to reuse technology from the LSST data management team wherever possible. Their pool of resources is significantly greater than ours, and we are not here to reinvent the wheel, if you're familiar with that phrase. So we have been keen to adopt their software and technologies wherever possible. And I should say, actually, their software and technology is all open source, so anyone can download, contribute, be part of the development of the software. Whilst the data is proprietary, the software is not. We're developing our implementation plan for the DAC, which will be actioned in phase B, actually. So commissioning of the telescope is due to start roughly halfway through phase B, and we plan to have a prototype DAC in place to be part of that commissioning effort. We're also developing the experience in the science community, so the PIs and the junior associates, so that they know how to use the tools and are familiar with the capabilities of the tools and the services right now, so that when LSST begins operation, they are ready to go. They don't need to spend time familiarizing themselves with how to use the data, how to access the data. They're ready from the beginning. And we have, I think, reasonable influence in the international IVOA standards bodies. And so we have been working in those bodies to ensure that the needs of LSST are recognized and potentially factored into future changes to the standard. Of particular interest there is the IVOA standards for transients, which are designed for low frequency events, the kind of thing you would get from a gravitational wave detector, rather than very high density events as we expect to get from LSST. And as I noted earlier, this is complemented by a program of development work which is about identifying and preparing to create UK user-generated products, which would typically go back to the community for wider adoption and use. Yeah, I've said that before about adopting the LSST project software and services whenever possible. So one of the activities we've looked at recently, for example, is an evaluation of Qserv. Qserv is the name of the database technology that is intended to run or to host LSST catalogs. It's, in simple terms, a distributed MySQL database. Early on in the project, LSST did a survey of database technologies and concluded that there was nothing available at the time that would be able to serve the 35 billion objects that LSST would be able to detect, would observe for the community. And so they embarked on building their own database, which is called Qserv. So here in the UK, we have a deployment of Qserv running on a testbed infrastructure. It's a fairly alpha piece of software, I would say, at the moment. It is not ready for use in anger by the astronomy community. There are a number of issues with it, but by having a version running, we are able to do a number of important tasks. First of all, it gives us an opportunity to engage with the community about things like the kind of queries that they will be interested in running, so we can think about how to organize our data, how to structure and index our data. And it also gives us advanced warning of the challenges we will face in running a DAC. So, for example, one of the key concerns we have is how we will ingest catalogs into our instance of Qserv. We're not just interested in hosting the LSST data. As I said earlier, we're interested in giving astronomers the opportunity to cross-match that to data from other surveys. And the easiest or the most sensible way to do that is through Qserv. However, Qserv is not designed to ingest non-LSST data sets. And because of that, there are challenges in so doing. So our instance of the testbed currently runs 2 data archives. It runs UKIDS and the Sloan Digital Sky Survey. Reasonably successfully, I should say. The form of SQL that it accepts is limited. It is not a complete implementation of SQL, and it is very easy to crash the database, which is not something you would want in production, which is why I say it's still at alpha. We haven't released it to the community yet, and we won't do so until it's more robust than it is today. But what we have done is, based on input from the community, created a benchmark suite. This is available to the public. I can send you a link if you're interested. There is some documentation, minimal documentation, I think, on GitHub, along with a selection of the queries. And we're using that to both test the database, but also to engage the community in how to write queries for LSST. Because we're going to be running on a shared infrastructure, we are also evaluating Qserv in a cloud environment. And in fact, we're using containers to do that. So our Qserv instance is running inside of Docker containers. And in fact, recently the project LSST has begun to distribute its software using Docker containers. So for those of you who might be interested in evaluating or using the software, potentially the Docker container route is a very easy way to get the software without the need to do local installs, dependency checkings and the like. But our Qserv instance runs in a cloud environment. The back-end storage is provided via a Ceph cluster. And then our cloud environment is actually running on OpenStack, and we are coordinating the containers using a Google technology called Kubernetes. Detail. I'll move on a little bit. Our aim is to automate the deployment as much as possible. And so we've been using some of the sort of topical technologies, Rancher, Magnum, which is an OpenStack technology, and we've also been working on automatic ingest. As I said on the previous slide, ingest is a very challenging thing to do with Qserv, and something that we want to make sure that we have as much experience of as possible in time for commissioning. Ceph, which is a scalable cloud-like storage, is not particularly new, but there are some innovations in Ceph that are potentially interesting for us. One of them is a file system called CephFS, which is advantageous for us because it allows shared access, which is more in the spirit of our approach to containerized computing. And we're also looking at how best to configure the hardware on which to run Ceph. So we're using SSDs for our journals, and we're comparing the traditional approach in Ceph to resilience, which is replication. And typically you create 3 copies of each data set on low-cost hardware. We're comparing that to what's more traditional in HPC, which is to use RAID technology. And we're also looking at the impact of different interconnect technologies on the performance of Ceph. So comparison of sort of 10 and 40 gigabit Ethernet connections versus InfiniBand, for example. The aim is to get as much performance out of a cloud-based deployment, but whilst maintaining that very much the ease of administration. So it is not an onerous task to run this cluster. Lasair, which is a Gallic word meaning fire or flame. I didn't choose the title, but it's stuck and I think it's quite appropriate, is our pilot LSST community broker. And we have deployed this round about 12 months ago now as an actual operating broker for the Zwicky Transient facility, ZTF, that you may be familiar with. The advantage of ZTF for us is that it looks very much like an LSST stream at a lower rate. It uses the same technologies to deliver the stream to the community, and so we are able to use it to build up our experience of running a broker service. We ingest nightly alerts from ZTF, and currently we put them into a relational database where they are filtered, they're annotated by cross-matching against other catalogs we have access to, and in certain instances they are potentially available for follow-up. There is a public web interface that anybody can access. The URL is on the bottom of the slide there. If you go along to that URL, you'll find a reasonably basic web interface, to be fair, but hopefully a functional web interface, which includes some standard queries, opportunities to do some cross-matching, and also to create what we call watch lists and alerts, which means you can register interest in a particular portion of the ZTF survey sky or a particular type of event, and in the future at least we will be able to alert you when something is observed that matches those criteria. At the moment, that is something you save in a form on the website, and you can run interactively whenever you wish. So effectively it's a saved query, but the plan is in the future that that will become something that becomes a push notification that you can receive via a Slack message or potentially your mobile phone or something like that. Alongside the web interface, we have an early access program for a Jupyter Notebooks platform. That isn't public at the moment, it's by invitation only, but if people are interested to give it a go, we are open to requests, and if anybody does wish to partake in that, they're welcome to. It is a prototype, so there are some challenges with it, but it does give you access to this workstation in the web type environment that I mentioned previously. You may know all about Jupyter Notebooks, in which case I don't need to tell you more, but if you don't, as I say, it's a way to run a command line interface through a web browser and have access to workstation grade resources and the data close by without the need to set everything up. LSST is going to be around about 100 times greater data rate than ZTF, and so because of that, we're also doing some experiments to scale up our operation towards the LSST scale, and we're experimenting with a technology stack which is called SMAC for this. So SMAC stands for the 5 key components that make it up. There is a Spark query engine, there is Mesos, Akka, Cassandra, and Kafka. Our SMAC stack is actually SCK at the moment. So we have Kafka, which is a logging technology used to handle events and alerts in a streaming fashion. We have Cassandra, which is a NoSQL database, and we have Spark, which is a query technology that runs on that. Our experiments are reasonably early on at the moment, I would say. But we are able to create an LSST simulator, and so we can replay ZTF events at the rate that they would be produced by LSST, so that we can do sort of trials of LSST community brokers that way. The notebook platform, here's a couple of screenshots of it. So as I say, we have a suite of custom notebooks. They're set up with the LSST software tools and some standard astronomy tools built in, so there's no need to install the kit. And they have access to relevant databases, the ZTF database, and in fact, I believe some of the other databases and catalogs that we host here in Edinburgh on behalf of the community. Again, it's deployed in a cloud environment using OpenStack and Kubernetes. And as I said, it gives you a workstation class resource to analyze data. In the future, we also hope to be able to provide scale out onto HPC resources. So as well as being able to do interactive analysis of data, there is an opportunity to do more substantial computations in a batch mode. If you're familiar with cluster computing submission through systems like Slurm or PBS Pro, then you'll know all about HPC batch processing, and that's a function we plan to provide reasonably soon. Looking at some of the dev work, we're involved with the Dark Energy Science collaboration. Is there a question? Sorry.
No.
Okay.
I just clicked the button here.
That's okay.
Sorry.
I'm happy to have interruptions if people do want to ask questions. Yeah, we're involved with the Dark Energy Science collaboration. We're doing various things with the collaboration. They are running simulators of LSST intending to create simulated images of how LSST would see the sky. I didn't really explain that very well, but hopefully it made sense. So effectively, we seed a model sky with various interesting sources, and then we simulate how LSST would view them, and then we post-process those images to recreate catalogs of what we would expect to see from LSST.
Are you part of DC2?
We are, yes.
Okay, so
I think I might mention that later.
Okay.
Oh, so sorry, just another question. When
Sure.
can you see the simulations, and where in this? Even the website that we can see the simulation?
The simulation of LSST?
Yeah.
So in terms of seeing, I'm not sure. So what you can see if you're a member of the collaboration, and in fact, DESC is slightly more closed than some of the other collaborations. So to have access to the data, you have to be a member of DESC. But what you can see if you're a member of DESC is there are various cosmological archives containing simulated images and simulated catalogs. The DESC website has a list of all the ones they've produced to date.
Have you downloaded them to England, to the UK?
So actually right now we're in the process of doing that. So we have a group in University College who would like to have a local copy of DC2 image and catalogs from what's called the Cosmo simulation. You may or may not know what that. Okay,
yeah.
Good. You know more
I
about
was
that than
in a
me.
meeting just last week. So.
Oh, okay, right. So we are going to host a copy of that here in the UK. It's a modest-sized data set. I think it's a few terabytes.
Yeah.
In fact, our main interest from the DAC side is because this will give us some reason to do data transfer experiments.
Yeah, that's what we're planning to do too. Isadora,
Okay.
I think I think it was you that asked the question, right? I can answer
Yeah.
you afterwards, offline. Okay.
Okay.
Cool. So as you sounds like you know, these are pretty substantial calculations requiring large allocations of time on big US lab and European computer systems. So one of the areas we're working on is optimization of the simulations. I think it's fair to say that they have been written primarily for workstation class resources and so are not well suited to exploit the potential of the supercomputing resources that they typically run on. So we're working to rewrite some of that code to exploit parallelism, to exploit many core technologies, and hence both speed up the simulations, but also make more efficient use of the resources that DESC has been awarded. We're also part of the data challenges. So DC2 is ongoing just now. We have developed some workflows that will allow the challenges to be run on grid technologies. The worldwide lattice compute grid, which LHC has set up primarily for particle physics, but is also available to other activities. We have an allocation of time here in the UK and in France, and we are about to embark on part of the 2.1i simulation. We previously contributed to the version 1.2 simulation, which ran last year. And as I've already mentioned just earlier, we are undertaking some data transfer experiments with IN2P3 around understanding how to ingest catalogs into the UK DAC, but also to provide this Cosmos Sim catalog and image repository to the astronomers here in the UK. Yes, this is some of the earlier work, which actually I'm not sure it's worth really discussing in much detail. So one of the workflows that an astronomer here in the UK was interested in was around identifying and measuring the morphology of galaxies as part of their work on weak lensing. And typically they needed to be able to process a large number of galaxies very quickly. And to help them do that, we created a workflow again for the grid, which allowed them to run the classification of 30,000 galaxies in approximately 80 hours, so around about 2.5 days. Now, unfortunately, LSST will be around about 1,000 times that, so we need to scale up the operation significantly if we're going to deal the same kind of workflow then. But in fact, we weren't constrained by scalability of the algorithms or the workflow we had in place. We were constrained by the resources that were available to us at the time. And so that 80 hours could easily be brought down by several orders of magnitude by deploying on a wider spread of resources. Classification of supernovae is another very interesting area in the UK. Particularly, there is interest in the Type 1a supernovae, which have in the past been used to measure the expansion of the universe. Because LSST is an optical telescope, it's actually potentially quite difficult to classify reliably supernovae events. And a team here in the UK based in Southampton and at University College in London have been looking at the impact that the survey schedule will have on the ability to classify supernovae based on their light curve. So as I said, on average, the telescope will visit every piece of the sky once every 3 days, but the survey schedule is not necessarily going to be uniform. And so this means that you don't necessarily get an observation of a supernovae every 3 days. You may get more frequent or less frequent. And they have been doing a study based on a number of candidate observing schedules to see what effect that would have on one's ability to classify supernovae. And the other area where I've been working on up until now on the engineering side is the development of the sensor technologies. LSST will have a very special camera which needs to be able to image in a very high resolution, but also very quickly. And the sensor technologies that are being developed for the camera are being constructed in the UK. There's some details of them there, and Ian Shipsey and his team in Oxford have been collaborating closely with E2V, who make the sensor technology to make sure that it is fit for purpose for LSST. If we look forward towards phase B, the first thing that we are planning to do is to actually deploy a fairly complete implementation of the DAC, of the Data Access Center that has been developed by the LSST Data Management team. We will use that for a number of early experiments with other telescopes, but also to be ready to participate in the commissioning activity for LSST. We are currently preparing our bid to be a community broker for the LSST alert stream based on the Lasair service that we run for ZTF, and our plans to do scaling experiments based on Lasair data and the ZTF functionality in more generally. We need to finalize our infrastructure provision and how it will run on the IRIS cloud resources. As I said several times now, this is not funded as part of LSST UK's main activity. We have to bid for these resources and secure a commitment from IRIS to provide what's needed for the community. And we're also looking to mature our plans to generate actual sort of first-class products for the astronomy groups, user-generated products as they're called in LSST. And finally, we're working actively right now on a concept of an international data access center network. This is something I think when we originally talked about this talk, I was going to tell you more about, but unfortunately, in part because of US government shutdowns earlier in the year, this has progressed more slowly than was anticipated. But what I can say just now is that there is a project ongoing to look at how we might set up an international network of data access centers to supplement the main center in NCSA and Chile. Some of the advantage we could expect to glean from such a network are new opportunities for science. So as I mentioned earlier, here in the UK, we see the being part of both LSST, Euclid, SKA, as being a significant advantage for astronomy communities. Now, the US, for example, are not currently part of SKA, so that is not on their roadmap. And they also don't necessarily have plans for joining together LSST and Euclid datasets, whereas we do here in the UK. It will provide more compute infrastructure for the user-generated analysis. NCSA has a reasonably large budget to support LSST operations and user analysis, but it is finite, and depending on the size of the community, people will see restrictions on their use of those resources. So by engaging more resources, we allow more astronomy to be done. It provides better scope for integrating user-generated products into the project. So for example, here in the UK, if we generate interesting user-generated products, we would be interested to contribute them back to LSST and for them to feature in data releases. And within a network environment, this would be more straightforward than if communities were more disparate and less organized. And finally, it will give greater availability and resilience. So potentially there are opportunities such as a 24-hour help desk. It wouldn't be limited to the time zones of Chile and the US, especially if there are data centers in Europe or Australasia, for example, covering most of the time zones. However, an international network of DACs would mean some significant new technical challenges. The first issue is that the data has to be distributed across those data access centers, and the data release products are substantial data archives, if you like. So over the 10 years of the survey, LSST will produce roughly half an exabyte of data, which will be hosted in data access centers, and getting that around the globe is not straightforward. There are dedicated network infrastructure in place between Chile and the US, and then between the US and France for processing, but there is not that same infrastructure in place across the wider community. We would have to piggyback on academic networks that already exist. It also increases the work and the complexity of the data management team, because they're now dealing with a wider range of platforms. They're dealing with centers outside the jurisdiction of the project, which also means that there are risks around enforcement of data access policies. As I said, this data is proprietary. Potentially it is easier to manage that proprietary nature if you hold that data in project-only resources. And once you expose it or you make it available via a community of resources, there are risks associated to that. So the working group is active. It is due to make a recommendation to LSST project and the corporation at the end of March. And I would hope that reasonably soon after that recommendation is considered and a decision is made, that the astronomy community would hear what the outcome is and what the opportunities are. I'm part of that working group, and I am happy to talk going forwards to people who are interested or want to know more as I can. I mean, some of the things we're discussing now are not public knowledge, but will be in due course. I'm happy to talk about what I can say, and also to feedback if people have things they would like that they think would be interesting for the working group to consider. So I think I've overrun my time. I'm very sorry, but I'll very quickly summarize where we're at. So LSST, as you're aware, is a very ambitious sky survey, and it will support applications from a range of different astronomy areas. In the UK, we are very excited by LSST, and we see opportunities across a number of different astronomy domains that are of importance here in the UK. It's also a very significant computing project. Elements such as the alert stream and the real-time analysis of data, but also the actual fact that it's a multi-petabyte data resource will be challenging, and are not the things that certainly in the UK we've considered previously in astronomy. And finally, we believe in the UK we are very well positioned to make use of LSST and to work with complementary data sets that we'll have access to from SKA, from Euclid, and from Gaia. I think that was my last slide. Hopefully that was interesting and useful. I appreciate time is tight, but I'm happy to answer a couple of questions now, or if people want to talk to me offline later, I'm also happy to do that.
Okay, George, thank you very much for our presentation. So we have time for a couple of questions. So do we have questions from the audience?
Well, hi, it's Julio. I'd like to ask you a question.
Hi, Julio. Okay, hi. Go ahead.
Hi, George.
Hi.
You're developing a platform to study small solar system bodies here at the Observatório Nacional. And we have interest to integrate the LSST alert stream in this platform. So well, in this context, which alert broker would you suggest to start with?
Okay, so at the moment there is only one alert broker, and that is NCSA. The decision about which community brokers will be selected and will participate in the alert network is still to be made. In fact, this is an ideal time to be involved. You may have seen around about 3 weeks ago, LSST put out a call for letters of intent towards creating community brokers, or bidding to host community brokers. The selection process will run over the rest of the year. I think there's an expectation that the decision will be made either very late this year or very early next year. But there will be a number of workshops running through the year at which the concepts and the functional requirements of this network will be ironed out. So actually, if there are specific requirements like that, it would be good to get those into the workshops. Now, you may be able to do that yourself. I can make an introduction for you or for your colleagues so that you can put these cases forward, or I would also be happy to try and do it on your behalf.
Okay, well, the basic idea, I think the broker, at least in our case, would be something simple. I'm not sure if we have to develop something special for that. Basically, we need, once that there is an alert, to select. I just want moving objects in the solar system.
Yep.
Already known or not. I mean, new discoveries or just a non-object, and take the position and the photometry from the and the observation time. Just basically, it's at least in my head, it's just that.
So I believe these are all in our plans for our bid for LSST. Possibly a good thing to do is to go to the Lasair website and have a look at what we're doing for ZTF just now. There is a sign-up option on that website, and it will give you the chance to actually introduce yourself to the Lasair team, and then you'll be able to talk about what you're interested in. We are developing the ZTF platform as we speak, and so we are entertaining requests from members of the community who would like different functionalities. What I don't know is how well ZTF sees solar system objects. You will probably know better than me about that. Is solar system objects something that's quite prevalent in the ZTF feed? So I don't know what, in terms of solar system objects, ZTF sees, whether you get a good selection from it or not.
I think so.
Well, yes, I'm not really completely aware of the ZTF broker for the ZTF for solar system, but I think in terms of moving objects, at least for the most distant ones, which are my main interest now, they seem to fit our needs.
Okay. So I think Luis said he thought that ZTF was a good source of
Actually,
solar system objects.
I want to intervene. I mean, since we're already pretty late, George, would you mind if we could set up a chat with you?
Sure.
Without being a webinar, because I have several questions for you.
Okay. Yeah.
So I'll probably write to you, send you an email, and we could schedule something more technical.
Okay, and that would be good.
As you know, I'm very interested in the setup that they're discussing about the international DACs. And
right. Yeah. Sure.
I wanted to know more about how the discussion is going. In fact, I mean, I have a meeting tomorrow with Steve Ken, and I think
good. Okay,
is going to come up again. So anyway, so I'll send you an email to talk about that, and I invite other people that may be interested, so that we can in a more informal format.
Sure. And what I can do is I can bring in one of the Lasair team too, so that maybe they can talk to you, Julio, about a bit more about what we're doing for ZTF, whether we could prototype some of that functionality with ZTF, whether our bid for LSST community broker status would fulfill your needs, or how best for you to feed those in.
Okay.
So probably not next week, the week after. Would you be available?
Yeah, that's better for me too. Next week is very busy, but I think
I'll send you an email. We can perhaps actually do a doodle or something like that.
Mm-hmm.
Thank you very much, George.
Thanks.
Okay, thank you. Sorry I spoke a bit longer than I intended, but
no, that's fine. I interrupted you. So.
Not very much, it isn't.
So, do we have any other questions? Quick questions?
Okay, I don't think I put my email on the slides, but if you want to share my email with people, that's fine, and then they can contact me if there's questions that come up later. I'm more than happy to do that.
Okay, thank you, George. So if we don't have any other questions right now, I'd like to ask everybody to thank George for his presentation. So George, thank you for your presentation. So
thank you so much.
Thanks very much.
Bye-bye.
I hope it was interesting. Okay. Enjoy your day, everybody. Thank you.
You too. Thank you.
Bye-bye.
Bye-bye. I have no idea how to disconnect, so this could take a while.